Now, let us look at the grade 11 revision now. So in grade 11, which is our objective for this lesson, we are talking about the Ogive curves. What are they? An Ogive curve is a smooth curve, it's very smooth, drawn by plotting upper limits of the class intervals of a group data against the cumulative frequency of the set. So what are we plotting? Upper limits against what? Against our cumulative frequency in that case. So our class interval in this case, for example, this is just a demonstration. So our class interval was representing age. So between 0 and 15 we had 0 frequency. That means no one was between the 0. So that means no one was at the ages or on the ages between 0 and 15. So that's why the frequency is 0 there. How do we find cumulative frequency? We always say this value plus that is equals to that. So we say 0 plus 14 is equals to 14. We take the 14 again. We're saying it's cumulative. It's accumulative. It's going up. It's increasing. So it's 14 plus 22. We get 36. So we go across and we go that side. So it's plus that side across. Then we get our answer on the other side, which is 14 plus 22. We get 36. We say 36 plus 30. We get 66. We say 66 plus 14. We get 80. Now how do we plot? That means in our cumulative frequency, it is rooted. We can see it is starting from 0. So when you reach it there at 0, so we're saying at 0, the class interval, which values are we going to plot? We said we are plotting against the upper limits. So our upper limits in this case is 15, 30, 45, 60, and 75. For the first data, so we're going to say age is 15. So the 15 is found somewhere there. So that's where we have our 15. And we have the frequency, cumulative frequency as 0. That's where it starts there. We proceed. When you go to 30, so this is the age 30. And what we have as our cumulative frequency, it's 14. So that's where the graph is. So it's 10. The 14 should be somewhere right there. Right. We proceed again. And upper limit is 45. We go to 45, which is somewhere here. Then we're saying, we check the cumulative frequency 36. 30, 36, it's in the middle. So that's why the value is right there. Right. So that's what we're doing on the Ogive curve. We look at the upper limit against the cumulative frequency. That's how we get an Ogive curve. Now, also, our Ogive curve, we can get data like percentiles. Percentile, it tells us which data is below a specific percentage. Q1 is 25th percentile, Q2 50th percentile, Q3 75th percentile. We move. All other percentiles can be calculated using this formula. So this Q1, Q2, Q3, we can find it like that. All other one position of the percentile is the percentile over 100 times the number of data set in a set. In this case, let's say for example 11 percentile of 70 values. So we are looking at the position of this 11 percentile. How do we find the value there? We're saying percentile is 11, so it's 11 over 100 multiplied by how many values? Our n in this case was 70 multiplied by 70. We get 7, 7. So we round it off to a whole number, we get 8. So where do we get the 8? On the Ogive curve, the set of 8 value, we find the 8th value on the vertical axis. So this one is going to be, remember this will be frequency. So it will be our position of the percentile is on the vertical axis. Then we check it, we extend it to our graph. Where it means the graph, where it means the graph, we just go straight down, perpendicular down. Then that is the value of the 11 percentile. So we draw the horizontal line from that 8th value. We draw a line going to that side and drop that line perpendicular. That means that line is straight down at 90 degrees perpendicular. Then to the horizontal axis. Then this is the 11 percentile value. So the formula gives us the position. Say the position is here position. So it is in the 8th value position. We take that position, we extend with a line, then the value it is found on the x-axis. That is to say, position of the percentile on the y value, it is the position, and the value it is found on the x-axis by doing what? By moving from that value, extend a horizontal line, and take that line and put it perpendicular straight to the x-axis. Then the value that will fall on is your percentile in that case. Now, let us look at this following example, grade 12. Now, the example reads as follows. It says, The table shows amount of time it took for a group of grade 11 to get ready in the morning. So the first one, it says estimate the mean of this grade 10 it took for to get ready in the morning. What is the model class? Complete the table and sketch the cumulative frequency graph, which is the archive, to represent this data. Number D, use your graph to estimate the mean of this data. And number E is interpretation now. So in this case, we're interpreting the data to say 65% of learners took less than a certain amount of time. What is this amount? How many learners took more than 35 minutes to get ready for school? Let us look at number 1. Remember, estimate the mean. To find the estimate of the mean, we start with the midpoint. So our midpoint for the first one is 5 times frequency. So it's this multiplied by that, we get our midpoint times frequency. Then second midpoint times that, we get that, and we do all for them. This multiplied by that, midpoint times frequency, midpoint times frequency for all of the data set. Thereafter, what you do, you add all of this. When you sum them up, we got 1195, and we sum the frequency also is 37. Our mean, remember, it is the sum of the midpoint times frequency over n. So our midpoint times frequency, which is this total, it is now 1195 over n, which is the total frequency, which is 35. Then our mean value is 32,30. Now, number B, what is the model class? The model class is the one with the highest frequency. The one with the highest frequency in this case is, we check the frequency, the highest frequency value is 15. It is 30, it's less than or equals to x, it's less than 40. Right, we move on. Now, we now look at number C. Number C says, give us the cumulative frequency graph, which is our archive curve. So what we do now, remember, we now find our cumulative frequency first. We say, okay, this comes here, this plus that is 1 plus 2, it is 3. 3 plus 12 is 15. 15 plus 15 is 30. 30 plus 5, 35. 35 plus 2 is, it's 1. It's 37. So this plus that, we are plus when we go that side, then it gives you the answer on that side. Thereafter, how do we plot it? Remember, we use the upper limits and our cumulative frequency. That's how we find it. And this upper limits in this case will be on what? Will be on the x-axis, and this will be on the y-axis. Now let us just check the first one. Remember, our cumulative frequency graph, it is always rooted, meaning it starts from 0 there. Even if the value will start at 10, it will just go from 0 and move from the 10 there. So it is rooted at 0. Then we say the upper limit or the lower upper limit of 10, the cumulative frequency is 1. We go to 10, we get the value of 1 there. 20, we get 3, the value of 3 there. Continuous like that. 40, for example, we get to 40, 30, 40, then we get the corresponding cumulative frequency as 30. We go to 50, 35, 50 now. Here's our 35 there. So that's our 50 value there. You can look at it. We go across in that way. Then you go and check 37. So our upper limit of 60, it goes to 37, 30, 35, 36, 37. That is where we find it. So that's how we find our cumulative or our archive curve, which is cumulative frequency versus our upper limit. So this becomes x, this will become our y. Right, we move on. Use a graph to estimate the median of the data set. Remember, this is a group data. So Q2 is equals to 1 over 2 into n. Our n in this case is the frequency, total frequency. Right, if we go back to our graph there, so what we do, we add all of these values, we'll get 37. That is to say 15 plus that will get how much? The total frequency of 37. So total frequency here is 37. So in this case, total is 37, 1 over 2 of 37. We get Q2. So this is the the y value. So how to find the x value? We take this y value, extend it to the x. So this is how much? 18,5. 18,5 we found here. We extend it. Where it means the graph, we stop. We draw a perpendicular line straight to the horizontal. That's where our Q2 lies, which is how much? 32. So 30, 1, 2. So that is our 32. That's where 32 will be found. So the Q2 value, remember how do you estimate? we find the position on the y-axis, we extend that position to the graph and extend to the x value. Then on the x value, that's where we have the value of that Q2. Now let's move on. Now we're looking at number E. Number E is the interpretation of a percentile. Let's see how it works. We are given 75% of learners took less than certain amount of time. What is this amount? First thing, what we do, percentile is 65. So 65 over 100 multiplied by n, which is frequency or number of learners. So it is 65 over 100 multiplied by n, which is how much? 24,04. Now, this 24,05 in this case, it will be found on the y. So the answer that you get here is going to be our y value. So our y value is 20,04. We extend to the graph. Where it meets the graph, we draw the perpendicular line going down straight to the y, straight to the x-axis. Then that's where we get our value as 36. So it's going to be 30, 1, 2, 3, 4, 5, 6. So that's where the 36 comes in. So that's how we do it. So this percentile value, or the percentile gives you the position on the y-axis. We extend the position from the y-axis to the x-axis. Then that's the value we are looking for. How many learners took more than 35 minutes to get ready for schools? So how many learners took more than 35 learners? So we say in the total learners, how many are they? How many learners do we have? We have total of 37 learners. They took more than 35 minutes. Those 35 minutes is from 36 going up. So that is to say, we take this 36 value. We are now reversing the question. What are we doing? We move up. Where it meets the graph, we get the value there. So that's why we minus them by the 24. So we minus 24, we get total values as 18 learners. Right. Now grade 12s, you will be given 10 minutes to complete this activity. Right, welcome back grade 12s. Now, let us discuss the solutions to this activity. Number one, so we are told that the table shows the information about the speeds traveled on N1 between Johannesburg and Pretoria. Complete the table, number one, A. Number B, complete the table and sketch the cumulative, which is archived to represent this data. Use your graph to estimate the mean median of the speed of traveled. Calculate the estimated mean, comment on the distribution of the data set, and what percentage of the vehicle travel less than or faster than 120 kilometers per hour. Now to complete the table, remember, we're just working with the table frequency, code this value as it is. So to get this, remember, we used to say this plus that. So how to get this value that was missing here? What we do, you say 11 minus 2, we get 9. We're reversing now. Then we say again here, we are given that 11 and 34, we're not given that. We say 34 minus 11, we get 23. So now when you go back, we minus this minus that, we get that answer. Right. So now we are here. We now have this 34. So 34 plus 31, we get 65. That's how we get that one. We have the 65 already. So you say 65 plus 27, we get 92. Then you say 92 plus 92 in this case. We don't have this space. Remember that as it is red. It's just the answer. We'll say 100 minus 92, we get our 80. So that when you say 92 minus 8, we get our 100. That was number one. Now, let's look at number B. Sketch or complete the table and sketch the cumulative frequency graph. Remember, to get the cumulative, it was completed already. We use the upper limits. So our upper limits will go to our x values, and this will go to our y. X, you can see there's an x here. So already it becomes easy to remember. Remember, it must be rooted. So it must start from the 0 there, then 50 and 2, 50, 2 is there, then we plot all the upper limits, then 70, then we get our curve as it shows right there. Then we proceed, number C. Now our number C says use a graph to estimate the median of the speed traveled. Remember, to estimate the median, what do we do? Q2 is equals to 1 over 2, our N in that case, it is the total frequency. So that is to say when you go back to our table, we add all of these values, then we get our total frequency, which is 100. Total frequency will correspond to this value there, the last cumulative frequency value. So it will be the same value. Now, 1 over 2 of 100 is 50. Where do we read this 50? We read the 50 on the y-axis. Go to the y-axis. Here's my 50. I extend from the 50 where I meet my graph. I go perpendicular down to the y-axis, then the value, the Q2 is found there. So the Q2 from the graph is how much? Is 100. It is found from the graph. Number D, calculate the estimated mean. Remember how we find the estimated mean? It is the midpoint. So you find the midpoint of the class interval, 40 for the first one, 60, 80, 100. So the midpoint multiplied by the frequency. All of these values, this multiplied by that, we get that. All of them, we add all of these multiplications. So we add all of these products to say, we add all of the products of f times x. We add all of them, we get 9,920. So that is our top part there, which is our sigma of f times x all over 100, which is the total frequency, which is the 100. Then we get 99,2. Now, looking at number E. So number E, it says, comment on the distribution of this data. When you comment on the distribution, grade 12, remember, we are now focusing to say, is this, in this case, are we saying, is it negatively skewed? Is it positively skewed? So we are looking at the skewness. Now, Q2, remember, it's 100. Our mean is how much? It's 99,2. So mean is less than the median, so the data is negatively skewed. How do we see this? Remember, our box and whisker will be as follows. Now, when you look at the Q2 value will be 100, will be higher. The mean is this empty space. So this empty space represents the mean. So the mean, when you go at this one, it's on a number line. This is more positive. This is negative. So the mean is below the median. It's found below the median. And again, when you look at your box and whisker, we're going to go through this later. The major part, it represents our median, our mean. Remember, our mean is where the most or the majority of the data set is found. So it is here. It's on this empty space. So it is negatively skewed. As you can see that the median is greater than the mean. And you can see that now the tail will be on the side. We'll discuss the tail when you proceed again. This is grade 10. You should remember from grade 10. What percentage of vehicles travel faster than 120? So the total of them is 100. So how many vehicles do we have there? We have 20, 80 of them that travels faster than. So we are saying in this case, how many of them that we're having there? We're going to say 100 minus 80, then the 20 vehicles are the one that travels faster than 120. Then we say 20 over 100 multiplied by 100, we get 20% of the vehicles. Now, let us move on. Now, variance and standard deviation. What do they do? Variance and standard deviation of the ungrouped data. Standard deviation is the measure of how dispersed the data is around the mean. That is to say, how far apart or how spread out is our data around our mean. So, our low standard deviation shows that the data lies close to the mean. So, when the standard deviation is too low, that means most of the data parts or data sets are found closest to the mean. When the standard deviation is high, that means our values are spread out. So that means are spread out away from the mean. So most values are not close to the mean, they're spread out away from that mean. Then remember, the square of the standard deviation gives us our variance. So the variance measures the variability of an average or mean. So the small change in numbers of the data set equals to what? A small variance. So the variance, we talk about the change. So it is the variance, is the change that took place at a certain point. So when you say high variance, that means there was a big change. Small variance, there was a small change. That is the comparison that we're having on the mean and the standard deviation. To calculate the mean and the standard deviation, we normally use a calculator. So these are the calculator instructions that we have done. So first one is the step, the button to press, and the method, and what is going to be displayed in our calculator. So using a scientific calculator, step 1, find mode. Then when you press the mode, you're going to see the list of various modes. Number 2, press state. Then you're going to see the list of options in state. Then input each step 3. What do we do? Press 1, which is 1 minus var. So you look for this. Sometimes the options there of state might not be on 2. But what you should look for the weight state. In this case, number 3, look for the weight 1 dash VAR. So you just look for those weights if it's not following that number there. the list of table to input values. Then you input each value. After they are one after the other, you press the equal sign. 3 equal, 4 equal. We proceed in that sense. Number 5, once all the data is entered, you press AC. When you press AC, you will see it's going to show 0, the calculator there. Then shift 1 state. If your one doesn't give you, button number 1 doesn't give you the state, just look for any button that is written state on top of it. Then you're going to see list of options. Then you look for the one of 4, option 4, which is VAR. Remember, if VAR is not on or VAR is not on option number 4, so just look for VAR, press that option. Then number 1, you see that N. Number 2 is a mean, which is X bar. Number 3 is standard deviation. Number 4, we won't use it in the statistics of grade 12. Now, number 1, number of entries, it gives you N, is the number of entries to say how many entries you have entered. Number 2, it gives you the mean. Number 3, it will give us standard deviation. Now, if you are looking for mean, you press 2, you say equal sign, then you get the X, which is our X bar, which is the mean value. Then to find the standard deviation, repeat from step number 6, just press AC after getting the mean. Then go to number 6, which is shift 1, start again. Then you get press 7, 8, then you go and press number 3. You get a standard deviation. You get a standard deviation value in that case. Now, let us discuss this example, grade 12. Now, the grade 12 says, the table shows a list of deaths in thousands prevented by the use of antiretroviral treatment in various sub-Saharan African countries. So country of Angola, Botswana. So they give us the number of deaths. Number 1 says calculate the mean. Number 2 is standard deviation. How many are within 1 standard deviation? And what is the percentage of the values that are more than 2 standard deviation? To find our mean, we follow the calculated instructions. We find our mean as 10. Our standard deviation, again, we follow the calculator instructions to find that standard deviation. Now, how many observations are within 1 standard deviation? That is to say, we are going to determine within 1 standard deviation using the interval mean minus the standard deviation, and the second interval is what? X bar plus our standard deviation. What you look at, or what you can see there, is we have a lower N and upper limit. So these are 2 limits that we're talking about. So in this case, we'll say lower, upper. So we are looking for how many observations are there. So we're looking for this observation. So this is our mean value. So when you say within 1, so plus our standard deviation is going to go to that side. Then to go lower, it's going to be minus the standard deviation. So that's what we're saying. So in this case, we're saying the mean value in the middle. So 1 standard deviation, it's plus standard deviation this side. Then this side will be minus our standard deviation. So that's what we're doing in this case. So that is to say mean minus standard deviation. So our mean is 10 minus 2,5. We get the lower limit as 7,5. And the upper limit is what? Is 10 plus. So the upper is just to be greater. So it's 10 plus 2,5, which is 10 our mean plus our standard deviation. Then we get an upper limit of 12,5. So what we do now, we say our limit is 7,5 and it's 12,5. So we count the data says that are within 7,5 and 12. It's what? It's the 9, another 9, 2, 3, 1, 2, 3, 4. Right. Then we check with between 7,5 and 12, 5, 6. So these are the ones that we are looking at. So those are the data sets that falls between within. So there are 6 observations that are within 1 standard deviation. So how many of them? So that is to say, these are the values that fall between 7,5 and 12,5. Those are our intervals. Then we look at number D, that are more than 2 standard deviation. That is to say, we multiply the standard deviation with the 2. So the same process, but multiply standard deviation by the 2 for both limits. Lower limit we get 5 and upper limit you get 15. So you're calculating how many values are between 5 and 15. So what is the percentage of these values that are more than? So this is not within. So here we're looking outside of this. So the observation outside of this interval is 16. There's only 1 observation. So here, the difference between these 2 questions, let's go back to this one. they say within. So this one we are looking at the values that are inside of the deviation. Then this one we are saying outside of this. So the ones that are inside are 1, 2, 3, 4, 5, 6, because of 5 and 15, and then 16 is the only one that is outside. There's only one observation. So there's only one observation that is outside of the interval. So that means the percentage interval is what? It's 1 over 8. So the total observations is 8 of them. It's 1, 2, 3, 4, 5, 6, 7, 8. So we have total observations that are 8. There's only one that is outside. So it's 1 over 8 times 100. We get 12.5% of the observations are more than the two standard deviation, as the question said. Right. Grade 12s, I'm giving you 7 minutes to complete this activity. Right, welcome back, grade 12s. Now, let us discuss the solutions to this activity. The activity reads, a group of people were surveyed about the number of WhatsApp messages they sent per day. The following were received. So we have the number of messages. Calculate the mean standard deviation. What is the percentage? So looking for the percentage within one standard deviation, and how many observations are within the two standard deviation. So the keywords here is within and outside. The mean, we use the calculator instruction, and the standard deviation, we use the calculator. Then what we do? We determine our intervals. Within one standard deviation, it's mean minus standard deviation. The second upper limit is mean plus standard deviation. So our mean is 47.93 minus our standard deviation 20.47. We do the same for the upper limit, 47.93 plus 20.57. So lower limit is that. So the lower limit is how much? 26.36. Our upper limit in this case will be 67.50. That is to say, we are looking for numbers that are between, we count the numbers between 26.36 and 67.5. How many numbers we have? We have 21. We count them on our data sets here. We have 21 values that are within that range. Then we say, okay, because they want it as a percentage, I will now say 21, there are 21 over the total data set, which is all of this data set. We count them is 1, 2, 3, 4, 5 until 30. So they are all 30. Divide by 30 times 100, we get the percentage. That means 70% are falling within the one standard deviation. Within the two, we are in within again, not outside. So within again, so mean minus the standard deviation, and we get an upper limit there of mean plus the standard deviation, which is times 2, because now we are saying within the 2. So within, the limits are between 5 and 88.5. So we go there, we're saying values that are between 5.79, which is more than 5, this is out now, and 87.75, 07. So we count all of those numbers. How many numbers are there? So we count all of them. Then we found that there are how many? There are 28 observations that are within the two standard deviation of the mean. Outside, you say 28 minus 30. Then outside will be how many? 2 of them are outside. And then if we can look at the 2 that are outside in this case, it will be that 102, and it will be which one again? The one that is higher than 88. That one that are outside is the 102 above 88. Right, so you get that one. I'm just looking for the one above 88. So you'll just find it there. So the remaining 2 are the ones that are not within the standard deviation. So that's how we are finding these calculations. Right, now let us move on. Skewed and symmetric and skewed data. So what we dealt with, we looked at the skewed data. The data is said to be skewed if there are items that are very large and there are very small values compared to the rest of the data set. Now, when the mean is equal to the median, we say it is normally distributed, we get a symmetrical data. That means both sides are equal. When the mean is greater than the median, so what are we saying? The data is skewed to the right. When the mean is less than the median, the data is skewed to the left. So symmetrical, we see this is one we call a balance shape, where the mean, median, and mode are closer together. So the mean must be equal to the median. So all of these three must be closer together. Then the shape will be normally distributed nicely there. So if you just look at that, it's going to be equal. So our graph will have the equal for both sides, right? If you can look at it in terms of the whole box and the whisker, so you'll have that situation right there, right? Now, let us look at right skewed. So right skewed, it means the tail extends to the right. So that means the tail is on the right. So that means there is a tail on the right here. You can see that we include both the box and the whisker. There is a larger space on the right from the Q2 to the right. It's bigger. So that means this is skewed to the right. And remember, this is the mean. So the mean, you can see in this case, is greater than the median because the median value is at this point. And you must also remember that the box and whisker, it is represented like on a term line. So if a term line is -2, that means any value, or let's say this is 2, this is positive values, then this maybe will be maybe 3, 4 going up. You can see the mean value will occupy a bigger value. The median value will have that lowest value in that case. So positive skewed, the tail extend to the right for both the box and the whisker. Right. Then we can see that in terms of our graph, we see that the mode will be the highest there. Most will give us the peak. Median follows, which is that value. Then the mean is here. You can see the mean because the values are positive 0, maybe 10. So mean is maybe 8. Then median maybe is 3. So you can see when you go that side, the mean has a higher value than our median. Negative skewed. So we are saying we are on the left side of it. So that is to say the tail must extend to the left. Where we are saying our mean will be less than our median. So our median will be greater. So where we find our mean there, you can see this is our mean. When you look at our box and whisker, then this is our median. So we can see that the mean value here, when you think of this as a term line, if this is 3, this will be 4, this will be 5, continue go that side. So the mean value is less than that Q2 is here, which is lower. 3 is lower than 5. So that's why the mean is less than 5. It becomes negatively skewed. So that's what we are dealing with in this case. Mode will be the highest, median, and the mean will be the lowest. So negative skewed, the tail extends to the left. Positive skewed, the tail is on the right. So that's why it's left skewed, because the tail is extending on the left. The other one is right skew because the tail was extending on the right. Identification of outliers. Now what are outliers? An outlier is a data value which is much larger or smaller than the rest of the value. This value will not follow the general trend of the data. In this case, in most cases, when you look at outliers, outliers are found mostly when we have things like errors. For example, let's say we're measuring the height of learners. Maybe we find that the height maybe is let's say, for example, 5 meters. There's no one which is 5 meters tall. So in most cases, the outliers, when you identify them, they help us to go back and read our data again to say, did we collect our data properly? Did we make a mistake, or was everything okay? So that's what outliers help us to do. So when you have a serious outlier, which is very high or very low, we go and check that value and see if there were no errors. However, I'm not saying outliers will always have errors. No. At times, an outlier is an outlier. So it remains as it is. Maybe so it remains as it is. But in most cases, outliers, they help us identify errors because they fall too far apart from our range or our data set. Now, lower quartiles, lower outliers are less than Q1 minus 1,5 of interquartile range. Upper outliers are greater than Q2 plus 1,3 of interquartile range. Now, example on the skewed data. So let's look at this one. The data below represents the speed in kilometers per hour at which motorists travel on a specific morning. So draw a box and whisker for the data, comment on the distribution, identify any outliers, and which central tendency best represents the speed at which the motorists have traveled. Now, number 1, box and whisker. Remember, we find minimum value. Remember, the first thing that we do, ascending order on our data. Minimum value is that 18. Maximum value is 82. The median, which is Q2, you find it 1, 2, 3, 4, 5. The 5 is 6. then this is the median value in that case. So this is our median. Then when you're looking for Q1, is the half of this is 1, 1 again, 2, 2, and we have 3, 3. So these two are going to give us our Q1. So that's why we say 48 plus 50 to give us Q1 divided by 2, we get 49, which is in the middle there. Then our Q2 in this case 74. It's between these two again, so it's here. So this is where our Q2 is. Then we plot that in our scatter, our box and whisker, the minimum value, Q1, Q2, Q3, and the maximum value. Number 2, comment on the distribution of the data is negatively skewed. Let's go back and verify this. Now, negatively skewed, let's see. We can see the tail extend on this side. And when you check the box here, the mean is here, it's lower. So our mean, it's lower than our median. So you can see on the left side is left skew, which is negative skew because this side is bigger than this side. So that answers number 2 for us. So negative skewed because in our box and whisker we can see that. Any outliers? So interquartile range is Q3 minus Q1. So we minus the 2, we get 26. So lower outlier, so we get the lower one can be 10, the highest can be what? 114. So any value that is greater than less than 10 is an outlier. Any value greater than 14 is an outlier. We don't have that value, so there are no outliers in this data set because no values are below 10 and none are above 114. Which central tendency will best represent this? It will be the median, as the mean is too low because the data is negatively skewed. So if the mean is low, then median will be the best. If median is low, the mean will be the best to give us the central tendency. Now, grade 12, I will give you 7 minutes to complete this activity. Alright, welcome back, grade 12. Now, let us discuss the solutions to this activity. So, we are saying time in minutes that 12 grade 11 learners spend on Snapchat per day is. Now, these are the data sets that were found for that time. So, the first question saying, draw a box and whisker diagram to represent the data. Identify any outliers. Which central tendency is best to represent this one? Remember, central tendency when the mean is greater than the mean is better. And when the median is greater than the mean, then the mean will be, so when the median is greater than the mean, then the median will be better. So the one that is bigger is the one that we saying is the best to identify. Box and whisker, find the minimum value, is 20. Remember to find this, you must order your data set to say from ascending order from lowest to the highest. Minimum, our maximum is them. Then we find Q1, Q2, and Q3. We look for Q2 first. It's better to do that all the time. So it's 1, 1, 2, 2, trial and error, 3, 3, 4, 4, 5, 5, 6, 6. Now we can see that our Q2 is found between the two values. That it means it's going to be 33 plus 33 all over 2. So 33 plus 33 gets 64. Divided by 2, we get 34. So that's why our Q2 is 34 in that case. Now, to find Q1, we start here. Remember now, this 34 will be in those two, between those two. It's going to be 1, 1, 2, 2, 3, 3. So again, 1, 1, just verifying, 2, 2, 3, 3. It is found between the two values there. Then we can see, add the 2 again, divide by 2, get our value there. Then it comes this side, it's 1, 1, 2, 2, 3, 3. Add the 2 again, then you get our median, our Q3 as 38,5. Then our maximum value is 50 in that case. Right. So then what we do now, we now plot this as or on our box and whisker. Then we find that 20, it's a minimum, 50 is our maximum. Then we have Q1 as 33, then Q2 is 34, then 38,5 is our Q3. That's our box and whisker. Identify any outliers. How do you identify them? A lower outlier, any value lower than 24,75 is going to be an outlier. any value that we have there, right? The upper outlier in this case, it will be what? Upper outlier, we have that, which is 35,5, which is our Q3, 38,5, which is Q3 plus 1,5 times interquartile range is 5,5, right? Then our upper limit is 46,78. So any value greater than 46,78 is an outlier. So we have that value, 46,78 is here. So this is the value. So 50 is an outlier. Any value below 24,75. 24,75 is somewhere here. Any value here. So the 20 again. So we have two outliers. 20 again is an outlier. So therefore 50 is an outlier and 20. So 50 and 20 are outliers because this is lower than 24,75. This one was greater than 46,75. Which central tendency is going to be best to represent the data? The mode. Why? Because the frequency of 33 minutes is 6. So we have, what is happening? We have a greater frequency there, right? So this is the one that we haven't considered to say mode will be best because we have a mode of 33 minutes, which is 6, which is high, and it will not be affected by any outliers. It doesn't matter how outliers are. Because of the mode of 33, it makes our data to be centered around the 33. So 33 becomes the better measure of central tendency. So central tendency, that means the most data will be centered around 33 in this case. So that's what we mean. When you say which method is better, we're saying the value that we have with it will be, if it's higher, it means that's where most of the data will be scattered, will be distributed around. So more mode, it means most numbers are around the mode. More mean, it means more numbers are around the mean. Greater median, it means more numbers are around what? The median. So that's what we are saying in that case. Now, grade 12, this is the homework, and I'll give you 5 minutes to copy down the homework. Right, now let us move on. So in this lesson, we have focused on our OGAF curve, which is cumulative frequency curve, which is an S shape, which is drawn by plotting the upper limits of class interval against the cumulative frequency. And we have calculated standard deviation, where we are measuring how dispersed the data is around the mean. That is saying how spread out is the data around the mean. Where the low standard deviation, it will mean the data is close to the mean. High standard deviation means the data is far from the mean, or the data is largely distributed. Variance is measures the variability from an average or a mean. The variance is to say how by what value is it changing? Is it changing by a high value or by a lower value? That is variance. By what value is changing with. Identification of outliers. We have identified outliers to say an outlier is a data value which is larger, or it can be too large. So, or it can be what? Too small from the rest of the values. This one is the value that is that will not follow the general trend of the data. So under outliers, what are we saying? We have an outlier value to say from these values, any value below this value is an outlier. Any value, an upper outlier, any value above a certain value, it's an outlier, which is an upper limit in that case. Right. So preview for the next lesson. So this is what we're gonna focus on our next lesson. Number 1. So we'll proceed with data handling statistics. Now we're gonna work with grade 12 content, where we're saying use statistical summaries, scatter plots, regression, in particular the least squares regression line, and correlation to analyze and make meaningful comments on the context associated with the given bivariate data, including interpolation and extrapolation, and discuss the skewness. So next lesson is going to be focusing on grade 12 statistics. Right. Thank you so much, grade 12. Now enjoy the rest of your evening.